All right, 10-3 part 3. Will 10-3 ever go away? I don't know, hopefully after today. So we are now simplifying radicals with division. So with division, if we see that we have a fraction or a division in a radical, we're going to simplify the radical on top and bottom. So this square root of 24/25 is really the square root of 24 over the square root of 25. Well, we know that the square root of 25 is 5. 24, let's see, we can break down as 4 and 6. 4 is 2 and 2. So we have 2 times the square root of 6 over 5. That is our simplified version of the square root of 24/25. Now, sometimes, though, it's not that easy where the bottom is a perfect square, and we might have to do something that's called rationalize the denominator. This means if we have to rationalize the denominator, we're going to multiply by a radical 1. I'll explain what that means as we do it. A radical 1 to eliminate the denominator's radical. So multiply by a radical 1 that eliminates the denominator's radical. So let's say we have the square root of 35/15. Well, first I'm going to take the step and say that that's the square root if we divide both by 5 of 7/3. The square root of 7/3. Now we take that and we say that's the square root of 7 over the square root of 3. Now, the square root of 3 doesn't break down easily like we wish it would. So what we're going to do is called rationalize the denominator. Here's what we're going to multiply this entire fraction by a 1, by a1. Notice that I said a1 to eliminate the denominator's radical. So what's the radical in the denominator? Radical 3. So if we multiply radical 3 by radical 3, we'd get rid of that radical and we'd have the square root of 9, which is 3. So we're going to multiply it by a radical 1, so square root of 3 over the square root of 3. And that's going to get rid of that radical in the denominator. So now we're going to be able to say that we have the square root of 21 over the square root of 9. And we just said that that square root of 9 is 3. So we have the square root of 21 over 3. Now, again, we don't mix inside radicals and outside radicals. So we have the square root of 21 over 3. That's it. Done. Now, if we have the square root of 3n over 8, now here's a situation where we can't simplify it inside. So we say that this is the square root of 3n over the square root of 8. Now, I'm going to do us a favor and simplify that square root of 8 first. And we know that that's going to be the square root of 3n over, hopefully by now, we know is 2 times the square root of 2. Now, I need to get rid of that radical 2, so what's going to be my 1, my radical 1? I'm going to multiply by the square root of 2 over the square root of 2, which gives me the square root of 6n over 2 times the square root of 2 times the square root of 2 is itself 2. So 2 times 2. So we get the square root of 6n over 4. And we rationalize that denominator. Now that went kind of fast, so let's think about this. We take the square root of the top and the bottom, each separately. The square root of the bottom, once we simplify it, we take that radical. We multiply it by a 1 of that radical. A 1 because it's the same thing over the same thing, which when you divide square root of 2 divided by square root of 2, that's 1. Multiplying it by that 1 doesn't change the value of that original expression. So when we take that 1, that radical 1, and we multiply it, we then get rid of the radical in the denominator, thus making it rational. A radical, a square root, is seldom is it a rational number. Now, what if we see we have these two terms in the denominator? Then we have to multiply by the conjugate, and we can call the conjugate is kind of the opposite of the denominator. When we multiply by this opposite of the denominator, we create a difference of squares scenario, which allows us to have a whole number. So if we have 2 over 4 minus the square root of 45, we take 4 minus the square root of 5, we take that minus, and we make it plus, and we're going to multiply by 4 plus the square root of 5 over 4 plus the square root of 5. Now, in our numerator, we'll have 2 times 4 plus the square root of 5. And in our denominator, we could FOIL these out like we know how to from our multiplication video, or we can notice that we have 4 minus the square root of 5, 4 plus the square root of 5, and we have a difference of squares if we think about it from our FOILing days. And we can say that we have 4 squared minus the square root of 5 squared. So let's distribute that numerator, 8 plus 2 times the square root of 5 over 16 minus, when we think the square root of 5 squared is 5 over 16 minus 5. So we have 8 plus 2 times the square root of 5 over 16 minus 5 is 11. And there we have it, folks. We use the conjugate to get 8 plus 2 times the square root of 5 over 11. Now over here we have 2 times the square root of 5 over 2 times the square root of 7 plus 3 times the square root of 3. We're going to set up that opposite, remember? And we're going to multiply by 2 times the square root of 7 minus 3 times the square root of 3 over that same value, 2 square root of 7 minus 3 square root of 3. So our numerator is 2 square root of 5 times the group, 2 square root of 7 minus 3 square root of 3 over, let's see, when we do our difference of squares, we have 2 times the square root of 7 squared minus 3 times the square root of 3 all squared. So let's distribute that numerator. We'll get 4 times the square root of 35 minus 6 times the square root of 15. Now be careful, we should always check if we can break down these radicals. Turns out 35 and 15 can't break down, so that's okay. Now, in our denominator, when we take 2 times the square root of 7 squared, that's like 2 square root of 7 times 2 square root of 7, which means we have 2 times 2, which is 4, times the square root of 7 times the square root of 7, which is 7. So 4 times 7, we get 28, minus 3 times the square root of 3, quantity squared. That's what that is, squared. So we have 3 square root of 3 times 3 square root of 3, so 3 times 3 is 9. Square root of 3 times square root of 3 is 3. 9 times 3, that's 27. So we get 4 square root of 35 minus 6 square root of 15 all over 1. 28 minus 27 is 1. So we can say that this is 4 square root of 35 minus 6 times the square root of 15. And there we have it, folks. We used division with radicals. Now, on our practice, we have radical division practice. We start off with here number 1, negative 3 over the square root of 2. We need to rationalize that denominator. So we'll multiply it by the radical that's in the denominator, square root of 2 over square root of 2. And we'll be left with negative 3 times the square root of 2 divided by 2, because now square root of 2 times square root of 2 is just 2. And now, there we go, we have it. Negative 3 square root of 2 over 2 is our rationalized version of that fraction. Have fun.